Okay, viewers, good afternoon, good morning, depending on where you're watching us from. This is Intellectuals and Skills. You're welcome. We're going to be having one or two things to learn today from the science world, of course. But before we begin to learn, please do well to click and subscribe. Click on the subscribe button to our Intellectual and Skills, and also share to your friends as well to learn from this. Okay, spread the good news to the world. All right, we're having physics today, and in the physics world we're going to be learning dimensional analysis. Yes, dimensional analysis. Now, what is dimensional analysis? In physics, we must have been learned about fundamental quantities as well as derived quantities. Now, when you talk about dimensional analysis, it's just a study of the relationship between physical quantities, okay, with the help of dimensions. Note the keywords: with the help of dimensions and units of measurement. So I will go again. Now, dimensional analysis, just like I said, with the previous knowledge of what we know about fundamentals and derived quantities, is simply the study of the relationship between physical quantities. Okay, I'm going to be telling us the physical quantities that we have, the dimensions, and the units of what? Measurement. Now, let me start with the physical quantities. Now, these physical quantities are the ones we are familiar with. Of course, we know that in the universe today, we cannot do without time. Of course, you know, sometimes we are at home and you're late for something. You look at your wristwatch or you look at the clock, and you think about time. So time is a physical quantity. And then we talk about length. Length, very, very important. You know, when you go to the tailor, definitely the tailor will need a measurement, and you see him write one or two things down. And what is he doing? He's trying to measure how long your arm or your shoulders or your legs, depending on if you're a male or a female. Okay, that's length. And then we talk about mass. Of course, every living thing and non-living thing has a mass. Now, these are the basic ones I'm going to be dealing with. There are other physical quantities, just like temperature. Okay, amount of substance, and of course, luminous intensity. But like I said, I'm going to be working with this. The reason being that time, length, and mass. Of course, you know, in your everyday life, you work with time, and in your everyday life, you move from here to one point or the other. It's still length, and then every living thing and non-living thing has a mass. So these three are the basic quantities we have in physics, and of course, the science world at large. So, like I said, I'm going to be working with these three. So now, this is the physical quantities. Now to dimensions. Now, what are dimensions? Dimensions is just representing these physical quantities in just their capital letters, simply put. Okay, take for instance, you have time. Of course, we know that the unit of time is seconds, because there are other units of time, but as the SI units, we have it, we say seconds. Now we have time, and time we can represent as T, capital T. Of course, you know this T becomes capital T. So this is a dimension of this particular quantity. Now, if you talk of length, okay, you represent it as L. Now you talk of mass, you represent it as what? M. So you can see that there's a relationship. Now, what relationship are we trying to establish here? Now take for instance, we know that the unit of measurement is seconds. This is meter, okay, and this is kilogram. Now, like I said before, this does not mean that seconds is the only unit of time. Of course, there's minutes, there's hours, there's days, there are months, there are years, okay. And therefore length you have meter, kilometer, centimeter, millimeter, decimeter, and the likes. And therefore mass you have centigram, milligram, decigram, kilogram, and what have you. But we're going to be working with the SI unit, which is the international unit widely accepted all over the world. So these are the various units of measurement. Now, how can we dimension a particular quantity in physics? Now, just like I did here, this is a single dimension for this. The dimension of time I said is T, the dimension of length is L, the dimension of mass is M, just in capital letters. Of course, you might see it in different textbooks that you have over there. For you viewers, especially those in the secondary school and their first year in the university, you might see it in definition in different forms, okay? All right, let's take an example. I think that will help us to explain better. Let's say velocity. Now, velocity as we have it is simply displacement. Velocity is displacement over time, meaning that the change in displacement as time changes, that's velocity. Now, if we want to dimension a quantity such as velocity, of course you know velocity is a derived quantity. If we want to dimension a quantity such as velocity, now we have displacement as the numerator, we have time as the denominator. So how do we do this? Now, displacement, as you know, is just synonymous with length, and its unit is meter, measured in meter, and time measured in what? Seconds. So knowing the unit is very, very important, is key, because if you do not know the units of these quantities, there is no way you'll be able to dimension that particular quantity. Now, if we say that the unit of displacement is meter and that of time is seconds, of course this establishes the fact that velocity is meter per seconds. Now, we can easily write this as meter per seconds. Now, the dimension of this would be for meter. Remember I told you that length is meter, the unit, this is the unit, and then the dimension is L. So we put the L, capital letter L, okay, per, okay, or over time, seconds. So which is L over T. So if you write this as this form, in this format, we have it as length per time. So this is the dimension of velocity, LT minus 1. So that's very, very interesting. So you can see that it's very simple to dimension once you know your unit of measurement. Now let's take another example. Let's take another example. Let's say acceleration. Now, what is acceleration? Acceleration is simply velocity over time. Acceleration is simply velocity over time. Now, we already know what our velocity is, which is LT minus 1. That's the dimension. Or you can come to the side and just put it this. Now, we know that the denominator here is time, and then we put our time. So, from the laws of indices in mathematics, you have to be very careful with this. From the laws of indices, you know, when this comes up, it takes minus sign. the power to the power of -1 as a power. So this becomes LT -1 multiplied by T -1. Can you see that? So this becomes LT minus 2. Very, very interesting, because this -1 here, the power, becomes -1 plus -1, which is -1 minus 1 becomes -2. So that is why we have LT -2. That is why the unit of acceleration is meter per second squared. Do you see that now? So if you know, I go back to what I said earlier, if you know the units of a particular quantity, be it a physical fundamental quantity or a derived quantity, that makes it easier for you to establish its dimension. Like I said from the beginning of this class, our dimension is just the study of the relationship of physical quantities with dimensions, okay, and the units of measurement. So this is the units of measurement, and this is the dimension of this particular quantity. You see how easy it is. So we can do one more example, and then I'll give you something to try at home, you viewers. Okay, all right, let me rub this off. Remember, you can still watch this video, okay, on our channel, and do well to invite your friends, okay, share the link so that others could learn. All right, thank you. So we can try one more example. Let's say force. Okay, good. Now what is force? Force is just simply the product of mass and acceleration. That's force. So force is just product of mass and acceleration. Mass times acceleration, that gives you force. Now, how do we establish the dimension of force? Of course, we know that force is measured in Newton, okay? But we are not interested in writing Newton now as the dimension. So, now, if our mass is kilogram, our acceleration, we already established acceleration here, if you can recall. It's just down here. You see that our mass is kilogram, which we can as well represent in the units of dimension, which is m. So you can see now that we can write our mass as m, okay, and then our acceleration lt -2. So you can see that the product of these two, this one is very easy to recall. Our mass, remember I told you that your mass, dimension m, length, and then time. So we're taking our n, and we've already gotten acceleration here. So we can just bring the two together. Okay, that becomes mlt -2. Very easy. Of course, sometimes this can be tricky when you are in a rush, but take your time to do well and learn this at home. So this video is always available on our channel, and there are more videos on our channel. All right, keep clicking and keep subscribing, and tell your friends as well. There are videos not just only in dimension, and also other topics that will help you grow academically and gain more knowledge as time goes. All right, so I'm going to give you viewers one to try at home. You can try the dimension of work. Yeah, viewers, I'm giving you this, okay, as to try this at home. I want to see your response in the comment box. I'll be checking the comments, okay, and I expect you to also share to your friends. Remember to click the like and subscribe button. All right, so work, I give you a hint. I know some of you might need a hint on that. All right, so I will be checking the comment box, and like I said, we'll be having more videos on this physics. I'll be having more videos as well in mathematics and other subjects as time permits us. So this intellectual and skills, I remain your tutor Ike, and see you in the next video. God bless you.